We need to find the total internal energy of a system. That system consists of 8 moles of argon gas and 6 moles of oxygen at temperature T. So if you have a gas at temperature T, then its internal energy, we can write it as NCVT, where N is number of moles, Cv is specific heat capacity for constant volume, T is the temperature. Since we have two gases, the total internal energy we can write like this: N1 Cv1T plus N2 Cv2 into T. So here the main task is to find the Cv1, Cv2 for the gas argon and oxygen. So argon is a inert gas. It is a monoatomic and it will have only 3 degrees of freedom. Generally, this Cv we can write it as n by 2 into r, where n is the number of degrees of freedom for that particular molecule. So since it's a monoatomic, which means it can move only along 3 axes, x, y, and z. Other than that, it doesn't have any motion. So the n value, the number of degrees of freedom for argon gas is 3. So Cv value for argon gas will become 3 by 2 r. And whereas when we consider oxygen, it is a diatomic. So like two atoms are there. In a single molecule, two atoms are there. It will be connected like this. So these two atoms can move along x, y, z axis. There is no constraint. So it will have 3 translational degrees of freedom. So the movement along x, y, and z axis is known as translational motion. So it has 3 translational degrees of freedom. That is fine. Along with that, this molecule can rotate also. So it can rotate about this axis, or like you can consider one axis is passing through this. So it can like rotate about this axis also. So it has 2 rotational degrees of freedom. Overall, it has 5 degrees of freedom. So the Cv value for oxygen is 5 by 2 r. This is for O2. Now we can find the total internal energy. N1 is for the argon, it is 8. 8 into, this is 3 by 2. 3 by 2r into T plus next oxygen. For oxygen, it is 6 moles. 6 into Cv, 5 by 2r into T. So this will become 4. 4 into 3, 12. 12 RT plus, and this will become 3. 3 into 5, 15. 15 RT. 12 plus 15, 27 RT. So the overall internal energy of this system is going to be 27 RT. Here we neglected this vibrational motions. We doesn't consider that the molecules vibrate. So we consider up to rotational motion.